Hi, this is John, working on 4Clojure problems. This one is number 44, rotate sequence, difficulty medium. What we want to do is write a function which can rotate a sequence in either direction. So we're going to make a function which takes in an argument n, the number to rotate, and then a sequence which will be rotated. And then we'll notice that -2 rotates it one way, +2 rotates it the other way. And then over here we have rotate with 6, so it looks like we can rotate and then keep rotating. So it looks like this is sort of a job for recursion. And what I'm thinking about is if we have a vector and we say we want to rotate 2, what we want to do is we want to pop off the first one and then stick it on the end. So that's sort of a operation for a vector, but if we need to go the other way, then we want to take off the last and stick it on the first. So if we're running conj, sometimes we're going to want to have a vector and sometimes we're going to want to have a list depending on which way we're rotating. So I was thinking, well, why don't we just make a decision which way we're going based on the sign, and then we'll define essentially how many times to do it off of that, and what are the operations, and what is the data structure as well. Okay? So we're going to start off with a let binding, and we're going to make just a map called ops. Alright, and we're going to make this map depend on whether we're dealing with a positive n or a negative n. So we'll say if n is less than 1, then we're going to return this map. Otherwise we're going to return a different map. Okay, so the first thing is what data structure do we want to have? Okay, so if n is less than 1, then we want to be adding to the beginning, right? We're going to be pulling off the n and sticking it on the front. Okay, so we want our data structure to be a list. Alright, in the other case, we want to have a vector. Now, we're going to be essentially popping from one side to the other, and on a list we want to be popping from the end. So our pop function will be last, whereas with a vector we're going to pop from the beginning, so our pop will be on first. Okay? And then the last thing we need to do is, whenever we're recursively going through there, we need to define how to call rest. Okay? And on a list, that's easy. The rest is just the rest function. On a vector, that's easy. On the list, we have the other case. We want to do everything but the last. Okay, and then finally, we'll handle the number of rotations uniformly. So we're just going to make an n variable, and what we will do is we want to assign it to be the absolute value of n. So if n is less than 1, then we want to multiply -1 times n. Otherwise, n is just going to be n. Okay, let's try that out. If we make our function rotate, let's see, let's move our let binding in down here. Okay, so here we have rotate with the n equal to 2, so that is greater than 1, so we ended up with a vector. We're going to pop on first, rest will be rest, and then n is 2. If we run the opposite case, then we are going to use a list. We're going to do last for our pop. We're going to do rest. For rest, we're going to do but last, and then finally, instead of n being -2, we transform it to +2. Okay, so now that we have that defined, we can do a simple loop and then a recur, and we are going to loop on let's see, we want to loop on n, and we can initialize it with n from our ops, and then also we will initialize our sequence. Okay, so terminating condition, if n is less than 1, then we're done. We return our sequence. Otherwise, we need to recur. Okay, so our n is easy, right? We're just going to decrement n. Alright, and here's where the tricky part's in. Now we're going to conj and our sequence and our value, basically. Okay, so the value is what we want to pop off of our sequence. So we will do pop from the ops. We're going to find our pop operation, and we're going to apply that to our sequence. All right. Let's see. Recur if loop let in the function. Okay. Last thing to do is take the rest. Okay, so we're going to do rest of the ops. So that rest of ops will give us the function that we need. Then we'll call that function on S. Okay, now when we call rest, it's going to give us a list back no matter what. So we need to transform the data structure into be the one that we want for our conjing to go in the right direction. Okay, so we're going to do a data. We're going to get the data store from our ops. And apply that to our rest function. Okay, so let's try that. Let's get rid of our variable here. Okay, rote2. There it is. 3, 4, 5, 1, 2. So that is working well. We'll go the other direction. Okay, now what happened? We broke things up into sublists, and that is most likely here, where when we called rest, we had a list, and then we called list again. So let's not do that. Since we don't need to change it, let's just call identity so that we don't transform anything. Let's try that again. And there it is. 4, 5, 1, 2, 3. 3, 4, 1, 2. 2, 3, 4, 5, 1. BCA and CAB. Okay, so it looks like our function worked. So let's just change the signature here. And let's paste it and see how we did. Green, 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 green. Great. All right. So Thank you for watching.